Hello, my dear class 7 students. Let us start learning physics, chapter number 6, part 2. Following topics will be covered in this video. Number 1, sound travels in the form of longitudinal wave. What is a longitudinal wave? That will be explained. Some terms related to a wave like wavelength, amplitude, time period, frequency, etc. Different types of sound, that is audible, ultrasonic, infrasonic, etc. And lastly, we will be discussing the characteristics of sound, that is about loudness and pitch. So children, now let us discuss how sound travels in air in the form of longitudinal wave. We have already seen that sound is a form of energy produced when a body vibrates. And during such vibration, the kinetic energy changes into potential energy and the potential energy changes into kinetic energy. The sound energy in air is transmitted from one place to another place by wave motion. And note that in this wave motion, the particles of the medium do not leave their mean position, but they vibrate about their mean position. Children, see, when a body vibrates, the particles of the air surrounding it also starts vibrating. And during such vibrations, they push or pull the nearby particles and transfer some energy to them. And this process will continue till the vibration reaches the ear of a person. So, such vibrations of particle in air are in the direction of propagation of sound and they form longitudinal waves. Now let us see the formation of a longitudinal wave when sound travels in air. In a longitudinal wave at point C, on either side of which the particles of air move towards the point C is called compression. Children, see in the diagram, you can see that a point where the particles move towards each other, that point is known as C, that is compression, and the point where the particles of air move away from the point, that is known as point R and is called rarefaction. So from the diagram you can see that a wave is a combination of compression and rarefaction, and please note that one wave is from a compression to the next compression or from a rarefaction to the next rarefaction. Let us now discuss graphical representation of a wave. The first one is a displacement distance graph. A longitudinal wave is graphically represented by the displacement distance graph as shown in the figure. This graph shows the displacement of the particle of medium at different distances at the same time. Children, you can see here two axes. One is displacement and the other one is distance. So this graph is known as displacement distance graph and it shows the displacement of particle of medium at different distances at the same time. The next type of graph is displacement time graph, and this represents the displacement of the particles of the medium with time at a given position. See children, this figure shows the displacement time graph in which you can see displacement on one axis and time on other axis. Time of one wave is represented by the letter T, which is time period. See, one wave, it's from one rarefaction to the next rarefaction and it is represented by the letter T, which is called as the time period of a wave. Let us now define some terms related to a wave. First one is one vibration. The to and fro motion which constitutes one full wave is called one vibration. That is, one wave is from one rarefaction to the next rarefaction or from one compression to the next compression. So the to and fro motion which constitutes one full wave is called one vibration. Next is wavelength. The wavelength is the length of a wave corresponding to one vibration, and it is represented by the symbol lambda, and it is measured in meter. You can see here in this diagram that wavelength, it is a length of a wave corresponding to one vibration. See, you can see in the diagram lambda, it is written. The third one is amplitude, that is the maximum displacement of a wave on either side of its mean position is known as the amplitude. In the diagram you can see small a. Small a is representing the amplitude of the wave, that is maximum displacement of wave on the either side of its mean position, and it is also measured in meter. The next term is time period. The time taken by a wave to complete one vibration is known as the time period, and it is always denoted by the letter T. In the diagram, you can see T, that is the time taken by a wave to complete one vibration, and it is denoted by the letter T. The next is frequency. The number of vibrations produced by the source of sound wave in 1 second is known as its frequency. I repeat, the number of vibrations produced by the source of sound wave in 1 second is known as its frequency, and it is denoted by small f or small n. The unit of frequency is hertz, which is denoted by the symbol capital H and small z. Depending on different frequency, there are different types of sound. So now we will be discussing about different types of sound. The first one is audible sound, that is the sound which is heard by human beings. Human ear cannot hear sounds of all frequencies. We can only hear sounds of frequency in the range from 20 Hz to 20,000 Hz. We cannot hear sounds of frequency below 20 Hz and above 20,000 Hz. And the range of frequency from 20 Hz to 20,000 Hz is called the audible range for the normal human ear. The second type of sound is ultrasonic sound. The sounds of frequency higher than 20,000 Hz are called ultrasonic sounds. We cannot hear ultrasonic sounds, but some animals like dogs, bats, monkeys, etc. can hear ultrasonic sounds. Note that dogs can hear sounds of frequency up to 50,000 Hz and bats can hear sounds of frequency up to 1 lakh Hz. Now children, how bats use ultrasonic sound? At night, bats easily move about without colliding with objects or obstacles. The reason behind this is that they produce ultrasonic sound when they fly, and when this ultrasonic sound comes back after reflecting from any object or obstacle in their way, they hear it and thus they understand the presence of the object or obstacle in the path and change their path. So this is how bats can travel very easily at night by using ultrasonic sound. The third type of sound is infrasonic or subsonic sound, and these are the sounds of frequency lower than 20 Hz. Sounds of frequency lower than 20 Hz are called infrasonic sound. We cannot hear this sound. For example, the pendulum of a clock makes one vibration in 2 seconds. That is, the frequency of sound produced due to its vibration is 0.5 Hz, and so we cannot hear the sound made by the pendulum of a clock. So children, the last table which is given here, this you have to learn by heart. It shows the frequency range of different sounds. So once again, let us see the frequency range. The below 20,000 Hertz frequency sound is called infrasonic or subsonic sound. Frequency range from 20 Hz to 20,000 Hz is called audible sound, and the last frequency above 20,000 Hz is of ultrasonic sounds. Now coming to the last topic of the video, that is characteristics of sound. A sound wave is characterized by its amplitude and frequency. That is, depending upon the amplitude and frequency of the sound wave, we have two following characteristics of sound. Number one is loudness and number two is pitch. Now we will learn in detail about loudness and pitch. Now we will discuss the first characteristic, that is loudness. The loudness of a sound depends on the amplitude of vibration of the vibrating body producing the sound. That is, loudness is a characteristic which will depend on the amplitude. And what is the relation between them both? That is, greater the amplitude of vibration, louder is the sound produced. For example, if you gently pluck the string of a sitar or guitar, a soft sound is heard, and if you pluck the string very hard, it moves from its rest position. It moves more from its rest position, and so we can say that the amplitude is more, and so the loud sound is heard. Now in this graph you can see that two waves are shown, wave A and wave B. In wave B, the amplitude is more. Children, do you remember what is amplitude? Amplitude means maximum displacement from the mean position. Maximum displacement on either side of its mean position. So in this diagram, you can see wave B is having maximum displacement compared to wave A. Therefore, we can say that wave B produces a louder sound when compared to wave A. Loudness can be defined as follows. Loudness is a characteristic of sound which distinguishes a loud sound from a feeble sound. The loudness of a sound also depends on the area of the vibrating body. And what is the relation? Greater the area of vibrating body, louder is the sound produced. So very simple example we can take here, that is, if you have two drums, one small and the other big, and if you are beating both of them to produce vibration, we will see that the sound produced from the big drum is louder than that produced from the small drum. So this shows that loudness of the sound also depends on the area of the vibrating body. If the area is greater, then the sound will also be loud. Children, we have already seen that loudness of sound depends on the area of vibrating body. Now let us see one activity which shows the dependence of loudness on the amplitude of vibration. So here, place a ping pong ball on the membrane of a drum. Beat the drum gently with a stick. A feeble sound is heard and you can see the ball hops up and down slowly. Now you will beat the membrane harder with the stick and the drum produces the louder sound, and also you can see that the ping pong ball jumps higher. Now this means what? That the loudness of the sound also depends on the amplitude of vibration of the vibrating body. Second characteristic of sound is pitch. A pitch of a sound depends on its frequency. Children, do you remember frequency? What is frequency? Frequency is the number of vibrations produced per second by the body. A sound of high frequency is said to have a higher pitch, while a sound of low frequency is said to have a low pitch. Now look at the diagram given. There are two different graphs showing different frequency. Wave A is with low frequency and wave B is with high frequency. So from this figure, we can conclude that pitch of wave B will be higher compared to the pitch of wave A. Remember that pitch depends on the frequency. If a sound is of high frequency, it is said to be a higher pitch sound, and a sound of low frequency is said to be a low pitch sound. Children, we have already seen that pitch depends on the frequency. Now let us see more about pitch. If higher the pitch, shriller is the sound. And if the pitch is low, the sound is flat or grave. Now let us see a few examples. The voice of a girl is shriller than that of a boy because the pitch of girl's voice is more. Similarly, the voice of a child is shriller than that of an adult. So now we can define pitch as pitch is a characteristic of sound which distinguishes a shrill sound from a flat or grave sound. We will see an activity which shows the relationship between the sound and the length of air column. Figure A shows a test tube with a little water in it. You have to take a test tube and fill little water in it. Now if you blow air into this tube by placing your lip on the mouth of the test tube, you will hear a sound which is flat, that is sound of low pitch. Now you have to add more and water into the test tube as shown in the figure B, C and D. And when the water increases, the length of vibrating air column above the water will decrease. And you will notice that when you blow air into the tube, that is in B, C and D, the sound produced will become more and more shrill. So thus we can conclude that the sound becomes shriller as the length of air column decreases. Here we have few more examples. Example number 1. If you place a pitcher below a water tap, you will notice that the sound produced due to vibrations in its air column also becomes shriller as the level of water in the pitcher increases. And second, if you take a postcard and rub it slowly against the teeth of a comb, you will hear a grave sound. But if you rub the same postcard against the teeth of the comb rapidly, the sound produced will be shriller. Thus, we can change the pitch of the sound by changing the length of the air column. Now, this is applied in musical instruments like flute and clarinet. In flute and clarinet, the pitch of the sound is changed by changing the length of vibrating air column when different holes in it are closed and opened. In stringed instruments such as guitar, piano, violin, the pitch of the sound can be changed by two ways. Number one is by changing the place of plucking or striking on the string, and number two by changing the tensions and the thickness of string. This is the reason why stringed instruments are provided with number of strings of different thickness and under different tension so that each string produces sound of a different pitch. Children, I hope the topics discussed in this video is very much clear to you all. The remaining last part of the chapter will be discussed in the part 3 video of the same chapter. Thank you.